Yeah, I'm like
1.5. We are doing infinite limits. So now we're not only looking at when x goes to 0, goes to 2, goes to 2 plus, we're going to infinity. So we're going to infinity on the left and the right, and then we're going to infinity on the y as well. Yes?
So this is going to be more like it's going to like an asymptote.
Correct. Very good. So let's look at an example. So one limit as x goes to 0 of 1 over x squared. 1 over x squared. All right. So we already know what does x not equal to? 0. X cannot be 0, right? It's going to make the denominator undefined. If you're not familiar with how this graph may look like, you could use graphing calculator to graph for now, but I'm hoping that you will be able to memorize this graph. 1 over x squared is this graph. Basically, everything trends up because you are squaring everything and you're dividing by that number. So then the closer you are to 0, the smaller the number it is. So then when you take 1 divided by that number, it becomes really big. Right. So then that is how the graph looks like. Now, if you remember your 1 over x graph, 1 over x graph looks like that. Basically, when you square everything, everything is positive. So then just remember this whole negative side flips up. So that's 1 over x. Okay. So the question is, what is this limit as x goes to 0? Infinity, or does not exist, right? So either one is acceptable unless I tell you that I want it very, very specific. You have to tell me which direction. So is it infinity or negative infinity? Then you got to tell me which one. If I didn't specify, then does not exist is totally fine. Yes?
Can we do like both, just in case?
Yeah, that's fine. Yes, Zach?
Can you put D and X because it looks cooler?
No. Okay.
You're right.
So you don't have to copy any of this down, so I just wanted to kind of give you a note. So first, infinity is not a value. It's a symbol that says forever large number. It's just super, 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 super large. That's what it's trying to say. It means expanding out of bounds. So like it's totally out of the normal bound. It's huge. That's all it's trying to say. So it's not a number. So don't ever think infinity is a number. Since it's not an actual number, we can say that the limit does not exist because it's not an actual value to represent the limit. So just kind of clarifying what infinity means. Next, vertical asymptotes. Let's review vertical asymptote. Vertical asymptote is that vertical line x equals a on the graph, so that the limit as x goes to a from the negative side of f of x is equal to infinity or negative infinity. So how can you tell if something is going to be a vertical asymptote? That's when the limit as x goes to that number a from the left-hand side, that's what it's saying, y is going to infinity or y is going to negative infinity. Okay, so that's a vertical asymptote. Or it could, come from the other side. So limit as x goes to a from the positive side, f of x is equal to infinity or negative infinity. So both of those will tell you that, hey, there is a vertical asymptote. It's not going to an actual number. It's going to infinity. Okay, usually this will cause the denominator to be undefined. So somehow it's undefined, the denominator does not cancel with the numerator. That is a vertical asymptote. All right, next one, very easy. Find the vertical asymptote. Find the vertical asymptote there. Okay, where is the vertical asymptote?
3.
X equals 3, right? And how do you know?
Whatever makes the denominator 0.
Okay, whatever makes the denominator 0, but since we are learning about limit, we would say because limit as x goes to 3, negative f of x goes to, this is a great exercise. Which direction? When x is going to 3 from the negative side, y is going where?
Negative.
Up or down?
Down.
How do you know?
Just plug in points and then change.
Yes, because plug in points. If you remember your graph, you will remember that if you're going from the left-hand side, you're always going down. Y is always going down. Now, in the case where you cannot tell which there's going to be many, and you would have to figure out what that number is, then you would plug in numbers. So plug in numbers is a great method. So if you cannot tell what's going on, from the left-hand side of 3, that is a number that's slightly smaller than 3, right? Don't try to calculate the actual number. It doesn't matter. Because you know it's going to be asymptote. It's going to be infinity. All you care about is it positive or negative? Okay, so 2 times 2.5, 2.9 doesn't matter, positive. 2.9 minus 3, negative. So that is negative infinity. So that's all you need to care about. We know it's definitely infinity because it's a asymptote. We just want to know if it's positive or negative. Okay, so don't try to spend a lot of time figuring out what that number is. It's not, it doesn't matter. Okay, so limit as x goes to 3 from the positive side, f of x. If you are not sure if it's going up or down, do the same thing. A number that is slightly bigger than 3, slightly bigger than 3, that's going to give you positive over positive, so that is positive infinity. Okay, so that's all you need to do. All right, let's try this one. Find the vertical asymptote. There is a tricky point to this one, so please be careful. Where is the vertical asymptote? All right, where is the vertical asymptote? Only negative 2?
Plus minus 2.
Only negative 2. Yes, good. Only negative 2. Positive 2 is a whole. Okay.
Wait, what?
So what you want to do is you want to always factor. So that's a x plus 4, x minus 2. In the denominator, you have an x minus 2, x plus 2. Whatever cancels creates a whole and not a vertical asymptote. So the only thing that's left over in the denominator is x equals minus 2. That is the vertical asymptote. Yes?
What's the use of calculating whether it's negative?
You'll have it later on. So sometimes, yeah, you'll need to know that. Okay, let's try another one. Vertical asymptote, where is it? Okay, vertical asymptote, where is that? Negative 1. Okay, so these are easy ones. These are the polynomial ones. We are not really going to do a lot of polynomials because they're the easy ones. So we are going to do a lot of the harder ones. So for example, this one. Hopefully you still remember how to do sine, cosine, all your trick stuff.
I purposefully forget them. Bringing them
Okay.
back up.
Yeah. So go ahead and try to figure out where the asymptotes are. So if you forgot how to do this, let's just go from the beginning. What is tangent?
Sine over cosine.
Okay, sine over cosine. What's going to create a asymptote? When cosine is 0. Okay, when cosine is 0. So this cannot be 0. So hopefully you still remember how to graph. I mean, at the very least, you got to remember that. Yes, but some people may not remember this. So cosine, normal cosine. Normal cosine starts. Normal cosine. What's the period? 2 pi, and then we break it into fourths. Okay, and then remember, normal cosine starts on the top, goes down, down, up, up. Remember, wherever cosine is 0, it creates the asymptote. So that is pi over 2. Pi over 2 plus minus pi n, and then n is integer.
Do we have to write that?
Usually on these kind of questions, you don't have to write any of this. You just have to know how to solve it. It's probably one of the multiple choice kind of questions. No, don't worry about it. Next, you gotta remember, natural log will come up all the time. Where's the vertical asymptote?
Yeah, me neither.
Chapter P actually you're... Okay, well, let's look at natural log first. Which one is natural log?
That one.
Bottom left, this one. Okay, so what is the vertical asymptote?
0.
Yes. x equals 0. Okay.
Wait, so can you what was it?
Sorry, let me write it out first. It's, let me try so it can be recorded. So it's this one. This is the natural log graph. You have to memorize this. Okay, so natural log will definitely be on the AP test.
Is the range infinity?
The range is all real numbers.
Or all numbers, that's what I meant.
Okay, so natural log, please remember it. And then any of these things that you're like, oh my gosh, I don't remember from pre-calc, there is a chapter I skipped in the book. It's called Chapter P. That's the prerequisite. You're supposed to know it before you come to this class. So if you don't know any of those, or you don't remember, inverse function, that kind of stuff, it's all in Chapter P. Please review it. We don't have a lot of time to review, so you'll have to review on your own. Okay, next. So infinite limits and normal limits have rules. It's kind of the same idea. So basically the rule is if C and L are real numbers so that you have two functions f and g so that the limit as x goes to 0 of f of x goes to infinity. So that function is going to infinity. Oh, I don't know why I put f again. Sorry. That should be g.
What rules are these for?
These are for the infinite limits. So when one of the limit is infinity. So what do you do? Or what's a fast way to think about it? So you have two functions. One of the function goes to infinity. The other function goes to an actual number L. Does that make sense? So you have two functions, f and g. When they're both going to 0, when x is both going to 0, f goes to infinity. So basically there is no limit, it's not defined. One of the other limit, so the limit for g, however, goes to an actual number. That number is L. Okay, when that happens and we are gonna do some operations to these limits, you can use these rules. First, sum and difference. So if limit as x goes to, let's say 0, since we're using 0, but it could be any number you want. And let's say you're trying to add these two limits together. Remember, at this point, f goes to infinity, g goes to a number. So what do you think the answer is? Yes. So you're adding a very large number with an actual number. That actual number is so small, it doesn't matter. Okay? So when you add infinite limits together, this is what happens. Next, you have multiplying them together. This one's a little bit trickier. Okay, so if you're going to 0 and then you have f times g, when L is greater than 0, what do you think this is going to happen? Infinity? The same limit, basically you're multiplying the two limits together and then one of them is infinity, the other one is L. This time L is less than 0. Negative infinity. Okay? Negative number times infinity changes that direction. Oops, sorry. So that is negative infinity.
Wait, why did you do both?
Because L is just a number, but when L is positive, it keeps everything positive. When L is negative, it will change the limit to the other side. Or pointing below. Now, third case. This is the hard one. When you're multiplying the two together, this time L is 0. Ooh, we don't know. This one is a special limit because you can't say 0 times infinity, infinity is gone. So you cannot do that. You cannot assume. So later on, we'll talk about what to do. That's a special case.
So what are we put
For now, we'll just know that this is like later. We'll do that later. We'll have to do that later. This is an indeterminate form. So anyways, no, it's later. So for now, just know you have a limit, infinity times positive number, positive infinity. Infinity times negative number, negative infinity. That's all you need to know. If it multiplies by infinity or multiplied by 0, we don't know. We'll talk about that later. Okay, Last one. Limit as, let's say x goes to 0 again, of g of x divided by f of x. Remember, g is going to a number L. F is going to infinity.
So then, is there a positive and negative one?
What do you think the answer is? Super small means 0. You're taking a number divided by infinity. Infinity is extra, extra, extra large. The number is nowhere in comparison, so therefore 0.
The other way is then.
Other way would be infinity. Yeah. Okay, so let's have you try these. Give it a try. I think you guys can do it. Okay, what's the limit on this one? Infinity. Good. All right, next. This one. What do we do? Did you guys try?
Yes.
Cotangent. Did you do something with cotangent too?
Yes.
Okay, you gotta try. You gotta try.
Can you show us? No.
Cotangent is what?
Cosine over sine.
Cosine over sine. All right. So we don't want to give up. We want to try as much as we can, okay? So this is cosine pi x over sine pi x. Now what?
Plug it in.
Let's simplify it first. Okay, so sine pi x times x squared plus 1 over cosine pi x. Now what? That was a cue for you to say plug it in. Okay, yes. So that is sine pi times 0 times 0 squared plus 1 over cosine pi times 0. Let's see what we get. Sine of pi times 0. That's sine of 0, right? What's sine of 0?
0.
Okay, yes. Please remember it's 0. You got to remember these basic ones. 0 squared pi plus 1, 1. Cosine 0.
1.
Cosine 0, 1. So this is 0. Okay, so please don't give up. You could have gotten the limit. You just kind of saw cotangent. It got you panicked. Don't panic. Remember, you know everything to solve these problems. Sine, cosine over sine?
Yeah, do you have to turn it or can you keep it as
Cosine over sine is in the denominator, so when you flip it up, it becomes sine over cosine.
No, but do you have to break cotangent up into?
You don't have to. It's just that a lot of people don't remember what cotangent looks like. So then,
And would you say going infinity or negative infinity?
in this case, it won't really matter because you have a number on the top, so it ends up being 0. Okay, next. Natural log. Please don't tell me it does not exist. You gotta tell me which direction. Okay, what's the answer? Hey, very nice. Okay, so basically this is the graph that looks like this. When you're going to 0 from the positive side, this graph is going down. So it's negative infinity. Okay? All right. One last one. What is the answer? Good. Negative infinity. Okay. Okay, so okay, so you can always break this up into 2 functions like this, or 2 limits, I'm sorry. So this first one is always 0, obviously, and then going to 0 from the positive side. Going to 0 from the negative side, this is going down, so that's negative infinity. So plus negative infinity, that's negative infinity. All right, really quickly, we're going to just review all your limit knowledge before we move on to the harder stuff tomorrow. First, what is the definition of limit?
Well,
Where it's going to? As it approaches to a number. So, okay, how do you prove that there is a limit? Okay.
Going to the same point and that point exists.
Oh, well,
it doesn't have to exist.
it doesn't have to exist. Okay, so limit as x goes to, let's say, a from the left-hand side is equal to the limit as x goes to the, a to the positive side, then you prove that that limit exists. Okay, so gotta use basic, you gotta remember this. Okay, what is the definition of limit? This is the definition of limit. Second, what does one-sided limit mean?
Oh, it's only from negative or only from positive?
Coming from one side, negative side or positive side. Does f of x have to exist on that side of x? I mean, it doesn't have to exist. It could be infinite limit, I guess, for a one-sided limit. That's okay. Third question. Oh, yes, we already did that. What's the requirement to prove that it exists at an x value? I'm sorry. What's the requirement? Yes, that one, the first one. And then, when can we apply the limit loss? When can you apply the limit loss? Limit loss like adding them, subtracting them, multiplying them, dividing them. When can you apply? Huh?
Two limits of the same limit thing.
What? No. Well, yes, they have to go to the same x value of. So they have to go to the same x value. Yes. Okay. So when one goes to infinity, the other one goes to a number. We can apply. Yes, limit loss. The other ones also apply too. But basically, both sides have two limits. If you were trying to use the limit loss, then they have to actually exist. Like whether if you're adding two numbers together, two limits together, and there are two numbers, or one of them is infinity. Yes.
Is number 3 like continuous at a point?
What's that?
Number 3, is that continuity at a point?
No, we're just talking about limit. We're not talking about continuity, whether it's continuous or not. Okay, now let me ask you another question. Can you have multiple vertical asymptotes for a function?
Yes. Possibly.
Yes.
Yes. Maybe. Not really.
Okay, be sure of your answer. Yes or no?
Yes.
That's correct. You can have more than one. Can you have two different horizontal asymptotes?
No.
No. Yeah. Wait.
No.
Yes.
No.
Yes. Yes.
No.
No. Break the vertical line test, right? Yeah.
Vertical asymptote.
because what if it's at the top and at the
Can you have more than one?
Possibly.
Yes.
Yes. Okay, so tomorrow we're going to talk about, yeah, right. So tomorrow we're going to talk about horizontal asymptote for a few days because it's harder than the vertical ones. All right.